This video tutorial will refresh you on how to find side lengths of right triangles using trig. The three trig guys we will be using today are sine, cosine, and tangent. But to use them, you have to know which side proportions go with which guy. So right now I have all these random letters just thrown out there on the smartboard. I'm going to rearrange them into kind of a color coding, if you notice it, and a word that a lot of you have seen throughout your geometry classrooms. So S, O, H, C, A, H, T, O, A. SOHCAHTOA. A lot of geometry teachers teach this word as an acronym to organize students' understanding or their relationships between which side goes to with what proportion. I'm going to change it up just a little bit. I'm going to do SOHCAHTOA, but I'm going to do SOHCAHTOA with the little guys here being in order: O over H, A over H, O over A. Still the same word, still the same letters. I just like that because it helps me now remember that the O goes on top, the H goes on bottom for sine. Or the A is on top and the H is on bottom for cosine, and likewise the O and A for tangent. Now before you use this, you got to make sure you know what the letters mean. Obviously the S goes to sine, the C goes to cosine, the T stands for tangent. But you also need to remember that the O stands for opposite, the A stands for adjacent, and if you don't like the word adjacent, I will tell you, you can also think about attached. Attached. And again, that starts with an A. And then the H is the hypotenuse. Okay, with those terms, let's look on the next slide at making sure you can pair up who is the opposite, who is the adjacent, who is the hypotenuse. So I have three triangles here, all right triangles, and I want to know who's opposite, who's adjacent, who's hypotenuse for each triangle. Now from this, the one that students see the clearest is always the hypotenuse. Hypotenuse is on the other side of the 90 degrees. So I have those all there, and you can draw an arrow and say hypotenuse. Draw an arrow, hypotenuse. Draw an arrow, hypotenuse. Okay. The ones that depend on where you're starting from is the opposite and the adjacent. So if I give you, let's say, an angle here, I'm referring to that's the position you're in. So I like to think about putting my eyeballs there and saying, if I'm staring through that angle, where is the opposite side and where is the adjacent side? Well, if you replace adjacent with attached, the question is this bottom side here, is he attached to your eyeballs? Or is this, go purple, side here attached to your eyeballs? And when you think about attaching versus adjacent, attaching is more visual for me, that this is the attached side or the adjacent side, and on the vertical part here, that happens to be the opposite side. Another way I think of the opposite is I take that angle, let's say it was like 20 degrees, and I take that O and I go O all the way over to opposite side. So if you have one over here, let's say you're dealing with this is your angle. What's attached to it, what's attached to this angle is right there. That's the attached side. You might argue that down here is also attached. That is true, but that guy's already labeled as the hypotenuse. And if he's the attached, then the opposite side is right there. Let's put some eyeballs or an angle right here. So again, if you want, you can think about having eyeballs. Whoever's right next to you, who's adjacent to you, who's attached to you, that's the adjacent. Leaving the other side, the opposite side, is your opposite. It is important to be able to label the A, the O, and the H because that will help you identify if you're using sine, cosine, or tangent. Now we're going to solve a problem. So here I have a right triangle with another angle of 15 degrees. And I have the x and the 40, and I try to color code for you that the x and the 40 are side lengths, they're the sides, and the 15 is an angle. And I want to solve for that x using a proportion using trig. So before I go sine, cosine, or tangent, I'm always going to label what sides I have. So I will try and do it in the same coloring that I had. Always opposite the 90. Or on the other side of the 90 is the hypotenuse. If my eyeballs are right here at the 15 degrees, I will have this be my attached side, which leaves all the way over here to be my opposite side. Now, I am trying to solve a problem that has x as the unknown and he's the opposite, but I do know the hypotenuse, which is the 40. So if I have the O and I want the O and I have the H, SOHCAHTOA, I must be doing sine. So when you solve this, you're going to write sine, and it's always of the angle. So sine of 15 degrees equals, and here comes the ratio, opposite over hypotenuse, x over 40. That's setting it up. Now we need to solve it. So we're going to take our calculators out, and I want to type in sine of 15. So a lot of you will go immediately and just say sine of 15, and you get a number. Before you agree with that number, I want you to make sure you are in the correct mode. There are degrees and there are radians. And in this right now, it's saying radians. I don't want that. So I need to go over to degrees and have it there. Now look what happens when I type in sine of 15. It's a different answer because that 15 was referring to degrees. Now this is shown on a TI 83 Plus, which is going to be similar to the 83 or the 84. If you have a different calculator, if it's your phone or a calculator online, make sure you know how to switch between degrees and radians and keep it in degrees. So when I have sine of 15 degrees, I get 0.259 equals that x over 40. Now I want to solve. When I solve, I like to think of this left side as always over 1, and I now see it as a fraction equals a fraction, and you can cross multiply, and you're going to get x equals 0.259 times 40. 0.259 times 40. I rounded. You could have used the whole answer if you wanted to, but you got x equals 10.36. Now, that was a side length, so that would be 10.36 feet. Okay. Now that was one using sine. Let's take a look at another example where we'll use a different guy. Again, 90 degrees. You have 25 is where you're starting at. That's what you're visualizing is from here. I want to find W, and I know a side length is 12. So first thing, figure out who's O, who's H, who's A. Across from the 90, that's your hypotenuse. Attached to your eyeballs is your A, which is the leftovers over here. On the complete other side of the 25 is the opposite. Now I didn't color code that time, I just kind of laid it all out. Now look at what you want and look at what you have. You want the hypotenuse and I have the adjacent. I have the adjacent. I want the hypotenuse. With the with the A and the H, you're going to be using cosine. So I'm going to do cosine of the angle. So cosine of 25 equals, order matters, a over h. So my a happens to be 12 and my h is w this time. A lot of times students think the variable, the unknown, always goes on top. Maybe they did 5 problems in a row in a textbook and it was always on top. That was just by chance. Don't assume the variable's on top. Make sure you know the order. In this case, cosine is a on top, h on bottom. Now we're going to solve this using calculator again. I know I'm in degree mode, so I can do cosine of 25. I get 0.906 equals 12 over w. Again, think of this as over 1. We're going to cross multiply and solve. This will be 2 steps because you're going to get 0.906w equals 12, but I need w by himself, so I'm going to divide by 0.906. I'm going to get 12 divided by 0.906, 13.25 feet. And that's how you got W. On the next example, everything's all in black. So this is what you would see more in a textbook, where you have the 20, the y, and the 70. There's no color coding, and you're just supposed to solve. So eyeballs here. Always find the hypotenuse first. It's the easiest one. Attached to the 70, attached to your eyeballs, is the adjacent. On the opposite side is the O. You want the A, you have the O, so you're going to be doing tangent. So tangent of 70 degrees equals opposite over adjacent. Again, the order matters, O over A. And from there you can solve it. Tangent of 70, 2.747 equals 20 over y. Set up your cross multiply. 2.747y equals 20. Divide by that 2.747, and you can get 20 divided by 2.747 equals 7.28. So that was one with sine, one with cosine, and one with tangent. I'm going to show you one more example that can throw a curveball to students when it seems to be that there are more info available to you. So this problem here looks just like one of the last 3 problems. You have a known side, an unknown side, and one angle. Here's the thing, 50 degrees, 90 degrees, you know a triangle adds up to 180. So sometimes a book or someone throws a 40 degrees in there to try and throw you off, saying, hey, I gave you lots of angles. So if I had the 40 there or if I didn't have the 40 there, it was always there because the triangle adds to 180. Now the question is, how do I solve this? What angle do I use? It will not matter. You just pick where you want to start and organize it. So if I pick this, if I have the blue guy there, I'm looking at this angle. Here's the opposite. Attached to it's the adjacent, and always across from the 90 is your H. So from this, I want the opposite, and I have the I have the hypotenuse. So if I have the hypotenuse and I want the opposite, I'm going to use sine. So I can do sine of 50 degrees, because that's the angle I'm at, equals opposite over hypotenuse. And then I would solve. Now, someone else might go, but I wanted to start at this corner with this angle. So if I am green guy looking there, notice across from the 90 is still the hypotenuse. Attached to the side is your adjacent, and on the other side is your opposite. Well, I still have my hypotenuse, but this time I want the adjacent to the green. So I have the hypotenuse and I need the adjacent, so you'd be setting up cosine of 40 equals x over 10. Two different equations, but try it out on your own. They will be the same.